Hello everyone, how are you all doing today? In this video, let's try to integrate a function which are of the type 1 over linear in sine and cos. Whenever you see a function which is linear in sine and cos in the denominator, what you have to do is we have to do Weierstrass substitution. Weierstrass substitution is a substitution where you have to put tan of x by 2 is equal to t. Remember that whatever is the angle in the original integral, in the Weierstrass substitution, the angle is always half. So if it was 2x over here, I would put tan of x is equal to t. Now in this case, since this function is a linear in sine and cos in the denominator, I can do Weierstrass substitution and say put tan of x by 2 is equal to t. Okay, since the angle here is x, I choose x by 2, half of that is equal to t. Now I have to convert that entire integral from the x world to the t world. Okay, in order to convert that integral from the x world to the t world, we'll also have to convert that dx in terms of dt. And in order to find the value of the dx in terms of t, let's find the value of x from here. Okay, then we'll find the value of dx. And in order to find the value of x, shift that tan on the right hand side. So therefore, you have x by 2 is equal to tan inverse of t. Okay, therefore, you have x is equal to, just multiply that 2 on right hand side, 2 tan inverse of t. Okay, so you find the value of x from here. After finding the value of x, what you do is differentiate both the sides with respect to x. Okay, if you differentiate both the sides with respect to x, you have dx is equal to, so we need to find the value of dx. So we get dx is equal to 2 dt divided by 1 plus t square. Because the differentiation of tan inverse t is 1 over 1 plus t square, which is why we have the value of dx as 2 dt over 1 plus t square. Now, in order to find the value of cos x, we have to convert that cos x in terms of tan of x by 2. Okay, and in order to convert that cos x in terms of tan of x by 2, we have to use a half angle formula of cos. We know cos 2 theta is nothing but 1 minus tan square theta divided by 1 plus tan square theta. This is the half angle formula of cos that will be helpful for us in order to do that conversion. So what we can do here is we can say that cos x can be written as, using this formula, you can write it as 1 minus tan square x by 2 divided by 1 plus tan square x by 2. Now, since the tan x by 2 is equal to t, what you can do is write that cos x is equal to 1 minus t square divided by 1 plus t square. Okay, so that's the value of cos x that we have. So now let's convert that integral from the x world to the t world. Okay, so the integral was 1 divided by 4 plus 5 cos x dx. So we can write that as integral of 1 divided by 4 plus 5. Instead of cos x, you can write 1 minus t square divided by 1 plus t square. Okay, and instead of that dx, we can write 2 dt. Instead of that dx, we'll write 2 dt divided by 1 plus t square. Okay, so we were able to convert that entire integral from the x world to the t world. Now we have to simplify this and see what do we get. So we have integral of 1 divided by 4 plus, and multiply that 5 inside of that bracket. So multiply that 5 with that polynomial. So you have 5 minus 5t square divided by 1 plus t square, and that 2 actually can be taken out of the integral because it is a constant value. So we can take the 2 out, and we have dt divided by 1 plus t square. Okay, we can simplify this a little bit further. We can cross multiply over here. So multiply this polynomial with this 4. So we have 2 times integral of, in the numerator I have 1 times dt is nothing but dt, and divide by, multiply this with this 4. So you have 4 plus 4t square, plus you already have that 5 minus 5t square. Okay, and here you already have 1 over 1 plus t square, and don't forget in the denominator also you have 1 plus t square, which is this one. Okay, after cross multiplying, you already have that in the denominator. Now what you can do is this denominator and this denominator's denominator can get cancelled here. Okay, so you can cancel this and this with each other. Okay, and after doing that, you essentially have a very simple quadratic polynomial in the denominator, which is very easy to integrate. So we have 2 integral of dt divided by, okay, so we have 4t square minus 5t square. So which is minus 1 t square. Okay, 4 plus 5 is 9. Okay, I hope that makes sense. So this can be actually written as 2 integral of, to make it look cleaner, we can actually write it as 9 minus t square. It's the same thing, right? And 9 is nothing but 3 square. So this is 2 times integral of dt divided by 3 square minus t square. Now in integral, there is a formula for this. For integral of, the formula is, let me write it over here. The formula to integrate 1 over a square minus x square with respect to x is 1 over 2a ln of a plus x divided by a minus x. Remember this formula. Okay, so let me highlight that formula over here. So we'll apply that formula in this integral. So if you apply that formula over here, we have 2 times, we have 1 over 2a. Remember that a is 3 over here. So we have 1 over 2 times 3 ln mod a plus x divided by a minus x. So 3 plus t divided by 3 minus t. Okay, plus let's add the constant of integration c over here. I hope that makes sense. This 2 and this 2 can get cancelled with each other, and you have 1 over 3 ln of. Let's convert it back to the x word. We know t was nothing but tan x by 2. So 3 plus tan x by 2 divided by 3 minus tan x by 2 and plus the constant of integration c, and this is nothing but the final result of the integral that we want to solve using Weierstrass substitution. How cool was that integral that we did using Weierstrass substitution? If you are interested in mastering calculus, you should hit that subscribe button today. I'll see you tomorrow.